Today we're going to talk about equations that have either an infinite number of solutions or no solutions. Sometimes equations don't just have one solution. They may have no solutions or an infinite number of solutions. If you solve an equation and get a statement that is always true, the equation has an infinite number of solutions. Alright, so let's check out example number 1. First thing I'm going to do is I'm going to apply the distributive property onto both sides of the equation. So negative 6 times x is negative 6x. Negative 6 times 7 is negative 42, or minus 42. On the other side, I have 3 times x is 3x. 3 times negative 6 is negative 18. Then I have a negative 3 times 3x, which is negative 9x. And negative 3 times 8, which is a negative 24. After the distributive property, I'm going to combine all the like terms together. I don't have any like terms on the left-hand side, so I'm just going to keep what I have, negative 6x minus 42. And then on the right, I have 3x minus 9x. Those are my like terms. That gives me a negative 6x. And negative 18 and negative 24 together making negative 42. Notice you end up with the same thing on both sides of the equation here. So this is another little trick. If you recognize that right away, you can see that you would have an infinite number of solutions. I'm just going to continue to work the problem so that way you can see what happens when you get something that is always true. Alright, so then I would move all my variables to one side. I'm going to add 6x on this side, and I'm going to add 6x on this side. These two will cancel out. They make 0, and these two also cancel out. They make 0. I end up with negative 42 is equal to negative 42. And this is something that is always true. I have two identical numbers on each side of the equal sign. Negative 42 will never equal anything besides negative 42. So that, again, is an always true statement. This means that there are an infinite number of solutions. Or you might see somebody write all real numbers. What this means is I can pick any number, substitute it in for x, and my equation will come out true. Right? If you have an equation, if you solve an equation and get a statement that is always false, then the equation has no solutions. So here's an example of that. If I look at the left-hand side of the equation, I have no distributive property, no like terms, so I'm just going to leave it alone, negative 29 minus 42x. On the right-hand side, I'm going to distribute 6, so 6 times 1 is 6. 6 times negative 7 is negative 42x. Alright, I'm going to try to move all my variables to the left, so I'm going to add 42x to both sides, addition property of equality. These two go away, these two go away, and I'm ending up with negative 29 is equal to 6. No matter how hard I try, negative 29 will never, ever, ever, ever equal 6. So this statement is always false, meaning that there are no solutions. As an added bonus in this video, we're going to talk about writing solutions in set builder notation. So this is another way to write solutions to equations. Looks a little bit unfamiliar to you, probably, but it's not terribly difficult to pick up. All right, we can write solutions to equations using a special format called set builder notation. Set builder notation looks like this. For equations with one solution, we put the brace, the variable, this little line means when, so x when, x equals, and then you put the solution. So typically your variable is x. Could be a, b, any letter usually, but this is your format. For equations with infinite solutions, we write the brace, variable when the variable exists in the real number system. So this is basically saying all real numbers in a fancy little format, and we close that one with a brace as well. For equations with no solutions, we draw a circle with a line through it, which means the empty set or the null set, meaning that there is not a single number in the set of real numbers that will make that equation true. Alright, so let's take a look at these three examples. Examples, to solve each equation, report your answer using set builder notation. Alright, so example number 1, We're going to start by applying the distributive property. I have a negative sign out here, so I'm going to distribute the negative sign. That's going to be negative 6a, negative 3, or minus 3, is equal to negative 2 minus 6a. Moving all the variables to the left, I'm going to add 6a, and I'm going to add 6a, using the addition property of equality. These cancel, and these cancel, and I'm left with negative 3 is equal to negative 2. That's an always false statement, so my solution is the empty set or the null set or no solution. Example number 2. I'm going to apply the distributive property on the left. So I have 2 minus 7 times 1 is a negative 7. Minus 7 times a positive 3x is a plus 21x. That's equal to negative 33 plus 7x. I'm going to combine my like terms on the left. 2 minus 7, that's a negative 5. So I have negative 5 plus 21x is equal to negative 33 plus 7x. I'm going to move my variables to the left. So I have minus 7x, subtraction property of equality. These two guys cancel. So I have negative 5 is plus 21 minus 7 is 14, so that's 14x equal to negative 33. And then I'm going to move the constants to the right, so I'm going to add 5 to both sides. These two will cancel, so that gives me 14x is equal to negative 28. And then using the division property of equality, I'm going to divide both sides by 14, and I end up with x is equal to negative 2. In set builder notation, we would draw the brace. Our variable is x when x equals negative 2. Yeah, just a little fancy way to write same thing that you already were doing before. All right, last example, example number 3. First thing I'm going to do is apply that distributive property. So negative 6 times x is negative 6x. Negative 6 times 4 is minus 24, or negative 24. On the right-hand side, I have negative 6x minus 24, no distributive property, no like terms, so copy it down. I move all my answers, or all my variables to the left, so I'm going to add 6x, addition property of equality, add the same thing to both sides. Those two cancel, and I end up with negative 24 is equal to negative 24. That statement is always true, so in set builder notation, I'm going to write x when x exists in the real number system. So all real numbers, or infinite number of solutions. Just another fancy way to write that.